All right. So, real world example. We started working with a company that picked up, I think it was between 5 and 8 companies over the course of 2 years, and they wanted to integrate a bunch of differentiated data. That data set in boxes, it's set in files that hadn't been scanned. So, we had to scan a bunch of data. There was a bunch of digital files, and it really scanned sort of an entire landscape of hey, what functional groups are represented? What do we know about these assets? How can we ascertain at a high level what these assets are and what we can do with them? But the first question they asked us is we picked up some midstream assets and we really want to understand how to optimize our disposal activities, reduce our total expense, and increase our profit potential on these assets because this is a new business opportunity for us. Now, anybody that knows anything about oil and gas knows that that's a really nuanced question. That's just not something that you can answer with a single repository of information. It's a multifunctional, collaborative piece of work to try to define how to do that at scale. And we built a system around doing sort of exactly that. So again, like we built this as a strategic thought partner at a high level. Now, we integrated roughly 1,862 new assets that they had purchased, and we tried to answer this question. How can we optimize our disposal, reduce our expense, and increase our profitability? Now, at a high level, we need a lot of differentiated data to do that. But we built a strategic thought partner. And again, you'll see all of these source nodes and references, and I'll show you what that looks like in a moment. But something that can look at the entire picture simultaneously, something that can scan the entire value chain and understand not just from a functional perspective, but from a business and a bottom line perspective, how we create value as a company, where our weaknesses are, where our strengths are, what our contracts say, and started to create a tool that you could use to not only understand the new assets that you picked up, but understand how to operate them more effectively for the overall business objective of making money. And ultimately, we had to ensure that we integrated a lot of multifunctional data, but we had to ensure that the fact base was correct. There was a question that was in the Q&A, and it was like, well, how can you, nodal references are nice, but like, how can you validate what you're getting? There's a couple of workflows there, right? Whenever we ask a question of a large language model, we're really sort of traversing what are very large pieces of information within a larger data universe that's contextually relevant to the thing that we're trying to define. And graph data science helps us get there. Traditional data science helps us get there. But it's really about retrieving the right pieces of that puzzle so that we can, at any point, understand what's important within the context of the question that was asked. Now, Dan showed nodal references earlier. That's nice, but at the end of the day, this is presented in this format so that you can see all of the different pieces of the puzzle that are being recalled simultaneously from each one of these nodes that are embedded semantically and connected across the data universe to give you the answer that was provided above. Now, this is a mix of internal information and open source information. Luckily, this is a heavily regulated industry. This is all public data, so I'm not showing you anything I shouldn't be showing you. But at the end of the day, the flexibility to sort of use both of these sort of internal sources and external sources, open source information to supplement your understanding of the assets that you picked up, allows you to do some interesting things and some fun things. So to do that, we had to combine all the wells performance information, all the saltwater disposal wells information, the history of performance on those assets, the drilling and completion schedule itself, our production forecast, our well water forecast, our historic water delivery and the efficiency that we got out of that system, the permits from the state. What does the permit say we can do with these assets, and how can we understand that at a fundamental level and connect that to a value chain optimization play? Understanding our costs that are in the agreements that we have in place commercially. Like there's different levers in each one of these agreements. They're all part of the puzzle. The infrastructure that's in place, all of our pipelines, all of our gathering stations, all of our surface facilities that we're using to connect all of these different 1,800 assets. To answer that one question, that highly nuanced question, you need about 7 different functions of information. It's targeted information, but you need multimodal information. So we're looking at structured, unstructured, semi-structured, transactional frequency data, and we're trying to build an ecosystem that we can operate within. And to do that, That's a non-trivial thing. It's about 5.5 million points of data to answer that one question. Like, how do we optimize our disposal activities, reduce our expense, and increase our profit potential? Now, when we deploy these things, we can get to the value in just a second, but because of the way we build them, I mentioned earlier, we define the who's, the what's, the when's, the where's associated to everything, and then we test everything within the structure of that model against each other to define the connections so that we can ascertain the whys and the hows. Well, in doing that, we start to build this ultra contextualized reality within a graphical context. And so when we do recall, we can do that on a semantic basis. And it allows us the opportunity to do really interesting things like perspective modeling and scenario modeling within the structure of these environments. So what we're showing right now is one of the questions we were asked from Civitas. Hey, we just purchased these assets. We don't know anything sort of in a micro context. We understand the top line, what they contribute, the dollars, but let's talk about the individual assets. Can you tell me from the perspective of a drilling engineer exactly what I need to know about these wells? And so what you'll see here is sort of an overview of the asset history, the depths, geometry, the well construction, the completion details, the technical analysis for wellbore placement is 100% in zone. You know, all of these things that are really important from an engineering context are sort of recalled. And then you have the ability to dive in through that context as an engineer to start to engage the data on that basis. But we also deal with things like accountants. And, you know, accountants are a huge part of how oil and gas companies like work on a day-to-day basis. The transactional density in these spaces are vastly different. So we needed to make a tool that could use the same integrated repository of information to answer questions that are geared towards the persona that we're trying to actually answer the questions to. And so this gives us a completely different view of this environment. It tells us what our financial metrics are, the production statistics, the well economics, the peak efficiencies, when we produce the well, what the economic assessment is, and some of the strengths and considerations for managing this asset forward. So from an accountancy perspective, from an asset management perspective, we can dive in on that basis. And it's because of the way that we build these models. They are inherently multimodal in nature. They allow us the ability to traverse complex relationships to find contextually relevant information, recall that information on query in natural language, and then present it to a large language model so that we can reason to and through it. Now, how that works in practical application is we know what we recall from the system. We know what we show to a large language model. We know what is returned from a large language model. We know the fact basis of those returns because we know what we provided it. And we know whether or not there's any hallucinated materials in the answers. And then we use human in the loop reinforcement to understand the value contribution of the answers that were provided. So we can go in and check the value. Did we recall the right pieces of the puzzle whenever we ask this question and reinforce those relationships that are value adding to answering those questions within this problem context? And that allows us to do some very, very interesting things. And I'll jump into two applications, but scenario modeling at scale is one of them. And document reasoning or contextual reasoning across documents led us to an accountancy workflow that we'll talk about really quickly. So let me jump into this. I'll just go ahead and say, just like everybody else, this is all synthetic data. These are sort of real companies in context, but everything else you'll see is fake, and it's for the purposes of this demo. So if we wanted to help the accountants and our analysts within our financial units as an oil company answer how to route cost effectively to the right AFEs, the right cost centers, and then reconcile it against the contracts that we've signed and the requirements there within. Like, what do we need to do to figure that out? Well, the first thing we'd need to do is aggregate all of our well counting information. We'd need to be able to understand, you know, the AFEs, the battery names, the pads, the cost centers, the pad names, who worked on it, when they worked on it, where they were. All of these things are really important. Which asset hierarchy are we operating in? The vendors, the supplier numbers, the historical codes that they have charged on, the historical locations they worked on, the historical phases they worked on, the cost centers that they're allowed to charge on. At a sort of more general level, what our pads are that are active right now, what our AFEs are that are active right now, what phase do they fall into? We also need to understand the wells basis we're operating from, and we need to understand from a chart of accounts perspective how all of these costs get routed across these different systems at different phases. And then there's sort of the bespoke area of this, which is the instructions that we can provide to the system to reinforce how we operate within this workflow. And so this all happens because we have the ability to work across what is a graph and what is a traditional database model and connect these two universes. We have something that's persistent and ever present in a graph that we use to reason to and through. And we do targeted recall on what is sort of a traditional database model and pull out when we need the targeted pieces of information that we need to supplement anything that we're doing from a graph perspective. So we can start to get really granular about detailed instructions for if you see this, even though within structure it should be routed in this direction, we know historically that the cost has been reconciled in this manner. Any rules about how certain suppliers should be treated at certain times of the year, any bonus or malus provisions, the ability to sort of take that entire workflow and take it from what is a very disaggregated, bifurcated information sort of space and bring it into a unified universal data model and then start to use these tools, what they're great at, what they're great for, to answer questions, creates value. And at the end of the day, we can get to a point very quickly where we can load up an invoice and we can ask a system, hey, tell me what you know about this invoice, where I should code this based on what you understand from the recall, and then tell me how I should sort of manage the expense at current. And so what we do is we're using AI for what it's good at. It's good at understanding language. It's good at understanding connections in language if you can feed it those connections. And we're defining not with 100% certainty here. We're not telling the people, this is exactly how you need to do it. We're allowing them to operate from a very narrow chamber of information that's relevant to the thing that they're trying to solve. So we're taking this universe of information, these like 6 million points of data across this graph, and we're distilling it down to its constituent parts that are relative to the query that we just ran and telling people, we think these are the right things that you should be focusing on. But more important than that is we're telling them why. And whenever we look at this, we're generating descriptions of the invoice that we're seeing, the wells that they're on, the vendor, what phase it was in, the AFE numbers, the invoice name, the operations, the contracting type from a procurement perspective. All of these sort of information points allow us to triangulate from a costing and a treatment perspective where these things need to go. And so what this did in practical application is we built this application on top of the other piece of data that I showed you before, right? Which is this big universe of data associated to all of these operations across Texas and New Mexico. And we built an application in about 6 weeks and started to pilot test it. And we defined that within structure, there's probably an error rate of around 3.9%, which equates to about $9 million in misallocated, misapproved, or misaligned cost that had previously been reconciled through the system. So we're trying to take this workflow, which in this system, because it's so disaggregated and so messy an environment, normally takes somebody between 10 and 30 days to reconcile a single invoice. Just think they're doing 10,000 transactions a day. Jeez. So a single invoice, 10 to 30 days. So let's call it an average of 20. And we're taking that entire workflow down to 2 minutes. So the intangible value creation for the people that are doing this work is exponential. Like Philip talked about the hockey stick. We're really delivering the ability to start focusing on the things that matter and not wasting a ton of time on the things that don't. And so this is really about augmenting people's capacity. This is not about replacing people. This is about creating better outcomes with machines and humans working together. And so we're trying to create solutions that help people be more effective, increase their capacity, and increase their capability. And this is a great example. And just this simple little application that we threw on top of this that was made possible by graphs has already created roughly $9 million of value. And as we scale that out to a broader set of work, we fully assume that it's going to create more. But that's just like one piece of the puzzle, right? The second thing that we did, I think that's sort of really important, is we built a tool which allows us to scenario model production facilities, our handling capacity on surface, how we treat water, how we dispose of water, how we do that on an economic basis, and how we handle any overages in the system at scale. And so what we're looking at here is an ability to, and on an objective function basis, clarify how to operate most efficiently in the day on a day-to-day basis, but more importantly, in a strategic construct, how can I design my wells, my facilities, my infrastructure at the lowest minimum cost to meet all of the upside that we could potentially capture from these assets. And so I'll walk you through this very, very quickly. But at the end of the day, what you're trying to do is compare different alternatives. And what you're saying here is we have alternative one, a pipeline connection, direct disposal, and frac tanks for holding the delta at the top. And over here, we have two disposal wells, we have no pipeline, we have a frac tank, and we have trucking. And so these are two vastly sort of different approaches to handling production and water within the structure of a producing oil and gas field. Now, we start from sort of the similar basis of give me all the wells, tell me everything you can about them, give me all the batteries, give me all the production forecasts, give me the disposal options, tell me what those are, water storage options. And then we built a system around a unified graph data model, which allows us to say at any point in time, over any range of time and any range of wells, how we can treat these things on the lowest economic basis. And so whenever we start to look at this, we have different options. Some are piped, some are not. This is the thing that you could sort of build in practical application in a planning phase to say, do I install a pipeline at a certain dollar per foot or dollar per mile? Do I like build a frac pond that is going to cost, anywhere between $2 and $5 million plus any of the remediation cost associated to it when evaluating these options? But you can start to select these things. And then you can look at your storage options. And again, this is just an example. You could build a library out of all of your storage options, all of your cost alternatives, all of your minimum fixed and variable costs associated to these things, and model all of those things simultaneously. You could figure out what is the best from a linear programming perspective alternative for how I can minimize risk, but still meet my objectives at the lowest cost function. So when you do this, you'll run a scenario. We can look at sort of the trucking. This will take a few seconds to run, but you have the ability to clearly see how alternatives and at any point sort of contingencies could manifest themselves and what that's going to cost you and what it's going to earn you at the end of the day. And so we're trying to use what is a unified data model to create an opportunity to do fairly transcendent things that traditional relational database models, even in an engineered capacity, are not even remotely close to doing without building some of the most intricate like Excel calculators that you would ever see. And so we're really trying to make this easy for everybody. When we push this out to production superintendents, we can see, hey, on a cost basis, like we're looking at a couple of different alternatives. We're going to dispose in these assets. We have these wells. If we're going to do trucking only, we know that on this day we need to handle 53,000 barrels, and we need to do it from these quantities from these wells on each one of these days. And we understand exactly where they're coming from and how we're calculating that basis. But at a top line, we can understand, hey, in this instance, this mix of different alternatives created an opportunity for, $1.7 million of cost that I need to outlay to manage these assets effectively. And we can quickly compare, whether or not these two things make sense in context. So again, we're starting from a universe of information. We're harmonizing this universe of information. We're creating the opportunity to understand how it's connected, why it's connected, and what it means for us as the owners of this information. And then starting to deploy applications on top of this information repository that are targeted in nature, that allow us to reverse really complex relationships and find contextually relevant information quickly and across information domains that are inherently disconnected. And that's probably the most important thing. Is we don't need to data lake this stuff. What you see here is a representation of information that is connected. These are persistently connected information pieces in the repositories they exist in now. And so that's why it's so important to kind of show people data in its native form. Now, we do create a graph and we use a graph, but this is so important. It's that connective tissue, as Dan talked about earlier. It's one of my favorite things to say because it's so real. Those connections matter. And we like to say to people, you're not missing data. you're missing the connections that matter within the data you already have.
Mm,
And if we can
wow.
start to think about that in that context, we can start to re-envision how we want to use information. And
Wow.
that really starts to open the door for value creation. In these instances, these two products together, these two applications have created roughly around $30 million of value in a year. So we're not talking about, potential. We're not talking about something that might be valuable. We're talking about something that's creating value on critical path right now in one of the most information heavy, disconnected, bifurcated, operated pieces of industry in the world today. And so
Wow.
it's really transformative stuff, but it starts and ends with the ability to get that information into a unified, harmonized data model. And to Philip's earlier point, the only one I know of that allows us to combine structured, semi-structured, unstructured, transactional data is a graph. And that's why we anchor on it. And that's why Neo4j is so, so important to everything that we're doing as a company and such a great partner for us.